Hello, my name is Don James, and I am a CFI based in the Dallas area. And today I'm going to explain and introduce the electrical system of the SR20 Garmin Perspective Plus Cirrus. As you see here, this is the Cirrus SR20 electrical system. This is a 28 volt electrical system comprised of a master control unit. Now, before we move forward, let's discuss what the MCU or the master control unit is. As we take a look in Chapter 7 of the POH, Airplane and Systems, on page 48, 7-48, we see that the master control unit is located on the left firewall. The MCU controls alternator 1, alternator 2, starter, landing lights, external power, and power generation function. The MCU is going to protect primarily for overvoltage up to 32 volts. Now that we have the MCU covered, let's talk about some other aspects of the electrical system. Let's move on to the alternators and batteries. Alternator 1 is a 28 volt, 100 amp per hour alternator. And we see alternator 2 is a 28.75 volt and 70 ampere per hour alternator. Both alternators are belt driven by the engine. And now let's talk about the batteries. Battery 1 is an aviation grade 12 cell lead acid 24 volt 10 amp hour battery mounted on the right firewall. Battery 1 is charged from the main distribution bus 1 in the MCU. Battery 2 is composed of two 12 volt 7 amp hour sealed lead acid batteries connected in series, and this is going to provide 24 volts. Both battery 2 units are located in a vented acid resistant container mounted behind the aft cabin bulkhead below the parachute canister. Battery 2 is charged from the circuit breaker panel, essential bus 1. Looking at this diagram, we see in the middle there's triangles pointing towards a wall or line. This represents a diode. A diode is something that allows electric currents to flow in one direction, or the direction that the arrow is pointing to. The next step is understanding the difference between volts and amps. I like to think of volts as water PSI or pounds per square inch. We're going to think of amps as gallons per hours in this scenario. Let's take a look at the main distribution bus 1 and main distribution bus 2. And in between, we have a diode in the direction of distribution bus 1 to distribution bus 2. We see that alternator 2 is powering that main distribution bus 2 and everything that is connected to it to the left. We know that it has a higher voltage, 28.75, or in our case, a higher PSI than alternator 1 with that 28 volt. Now we know that if these are two boxes or chambers filled with pressure, and that door hypothetically is the diode in between, if alternator 2 is running and working correctly, that's not going to allow, the diode is not going to allow pressure or water to go through into distribution bus 2. But we're going to discuss what happens when Alt 2 or Alt 1 is not operational. And in the event that Alt 2 is not providing the voltage or the pressure into that distribution bus 2, that diode allows, like a trap door, to open and allow volts from alternator 1 to travel through and power everything on the buses shown to the left. And it's got enough amps or gallons per hour to provide. Battery 1 has a direct line to the starter as well as the constant power bus, which has the caps, the parachute system, the ELT, and the convenience lights. Battery 2 has line to the essential bus 1 and essential bus 2 via the essential distribution bus. So for engine startup, during our pre-flight routine, we power up battery 2 first, prior to anything else. This is going to give us our GPS nav GIA 1, our COM 1, our ADAHARS 1, and our PFD. Another pre-flight check we like to do is once we have powered battery 2, we want to check to see if the flap position lights are not active. Now these are going to be on our non-essential bus. This is powered through the main distribution bus, which should not have power with battery 2 only active due to the diodes and the direction of the flow. Once we then turn on battery 1, that's going to send power through to the main distribution bus, which is going to power the non-essential bus, which is going to show our starter, avionics fan, lights, pitot heat, and those flat motor lights, as well as the stall vane heat. So recapping from earlier, we look at Alt 1, this is going to power main distribution bus 1, and we look at Alt 2, and this is going to power main distribution bus 2. In the event that we lose alternator 2, alternator 1 has a higher amperage than alternator 2. It has the ability to power alternator 2 and the main distribution bus 2. As you see on this diagram, we have a red X over the alternator 2. In the event that this is on an actual flight, alternator 2 will have an annunciator or message on our screen, and Alt 1 will actually pick up the load or loss from alternator 2. Let's take a look at a real-world example in an SR20 with a student and his instructor. As a simulated experiment, we're going to see the student turn off alternator 2. Upon this, we're going to immediately see that alternator 1 is going to carry or take the load of that alternator 2 to simulate that we have a real alternator 2 failure. This shows that we do not have to immediately panic. Alternator 1 is carrying the full load in this emergency situation. We simply look at our PFD and immediately notice that there's going to be an annunciator that pops up showing that alternator 2 is not working or not carrying any load. Now we're going to take a look at what happens if we have an alternator 1 failure. To recap, we know that alternator 2 can only power the main distribution bus 2 and the essential bus. And we know that the diodes and the direction of flow doesn't allow alternator 2 to flow backwards towards stuff that alternator 1 is powering. So we know that bat 1 is going to carry the load for all of this, such as AC buses 1, 2, constant power bus, and the main bus 3, which have some important things on there, such as landing lights, the yaw servo, USB power, the MFD, cabin fans, ELT, convenience lights, and the CAP system, of course. As we take a look at this diagram with alternator 1 in-op or not working, we see that we're going to get 3 CAS messages. Main bus 1, this just simply means that the main bus is going to be on battery power. Alt 1, this shows that the alternator is not working. And finally, we have bat 1, which just means that battery 1 is discharging for more than 30 seconds. Let's take a look at what happens in a simulated environment when the student turns off alternator 1. We notice immediately that alternator 1 is losing the amps, but alternator 2 is not taking the load. The system is designed for the battery to drain rather than alternator 2 to carry any sort of load. An alternator 1 failure does not mean that alternator 2 takes the load. That's only, like we discussed earlier, alternator 2 failing. Notice that he turned on the air conditioning, which pulls from alternator 1, or in this case, the battery, because alternator 1 has failed, therefore draining our batteries. Notice the CAS message of alternator 1 on the screen as we have simulated an alternator 1 failure. And finally, we see that once we turn alternator 1 back on, we verify a charge in the battery, and the load is back on alternator 1. Now let's take a look at the diagram with a dual alternator failure with both 1 and 2 not being operational. These are the CAS messages that we would be seeing. We would see main bus 1 and main bus 2, both of which just showing that we would be powered by the battery 1, alternator 2, both showing that we're not producing any power and that they are shut off. We see that the essential bus CAS message will be in red. This is just showing that the essential distribution bus is going to be battery powered. And bat 1 finally just shows that bat 1 will have a discharge. Let's take a look again at a real world example. With alternator 2 already being off, we then power off alternator 1, seeing that alternator 2 is not taking any of that load. And we also see a discharge with the battery, meaning we have nothing powering the batteries. We see the CAS messages illuminated on our PFD as well as cautionary down below. And finally, we'll see powering on alternator 1 and alternator 2. We'll start charging the battery and showing that the load is being placed back via the alternators. So under normal load, without shedding any load from the emergencies checklist, going through that checklist or the POH, the battery 1 will only last for about 15 minutes if we were to have a dual alternator failure or alternator failure 1. Whereas we see battery 2 here will last for about 45 minutes, give or take. So in the event that we lose electrical power, a dual alternator failure, or even an alternator failure 1, we're going to land as soon as possible, declaring an emergency, making it easy for ATC to help us get down on the ground as soon as possible. With that being said, this concludes the end of our lesson on the SR20 Garmin Perspective Plus Cirrus electrical system. Thank you for watching and tune in next time. See ya!